Okay, dear students, in the last class we have seen about the stress strain curve and other things. Okay, so all those ideas were discussed in the previous class. Then in the today's class we will see about modulus of elasticity and different types of modulus of elasticity. So there are mainly three types. One thing is Young's modulus, next one is shear modulus, next one is bulk modulus. So there are mainly three types of modulus of elasticity. So the word modulus of elasticity you must have heard from Hooke's law. Correct, right? In the proportionality sign I told you that the K is nothing but proportionality constant or modulus of elasticity. The same K will be discussed over here. Okay. Now what is this modulus of elasticity? Very simple. It is the ratio of stress and strain. Okay. It is the ratio of stress and strain. The three major types, okay, or the three types which are Young's modulus, shear modulus and the bulk modulus. Now we will discuss one by one, okay. First one is Young's modulus. So this Young's modulus mainly deals with the length, okay. Then if you take about this length, you must be knowing that it is a tensile or compressive, okay. So you have studied tensile stress and the compressive stress. Correct, right? Okay. So Young's modulus, it is the ratio of longitudinal stress, okay, we denote it by sigma, to the longitudinal strain that is observed. So this longitudinal stress or longitudinal strain are nothing but this are tensile and compressive. So this tensile and compressive are also called as longitudinal, okay. So Young's modulus is nothing but it is the ratio of longitudinal stress to the longitudinal strain. So we can denote it using y, that is equal to sigma divided by epsilon. Or the mathematical idea what you can get from here is nothing but y is equal to F divided by A, that is nothing but stress divided by strain. So I can write this term, okay, this term as F by A, then we take this term to the numerator, L, okay, L goes to the numerator divided by delta L. Now, what is the advantage of studying this Young's modulus? So, the study of Young's modulus will tell you how a material can be used for lifting, okay, or carrying something from one place to another place. I'll tell you how it is. So this delta L is nothing but change in length. Correct, right? We know that from the last class. When you apply some force on that material, there will be a slight change in the length. Okay, maybe increase or decrease. That is nothing but delta L. Now this delta L can be written as FL divided by AY. What is this Y actually? Y is nothing but Young's modulus. Now you see here, if the value of y is greater for a particular material, then what about delta L? See from this one, if the value of y is greater for a particular material, then what would be the value of delta L? Delta L will be small, right? So what is the meaning of this delta L is small? So if I apply some force on this one, okay, consider it as a material, or we take it as T. Now if the Young's modulus value of this one is greater, then I can produce very small change in the length for a large applied force. Okay, is it clear? If the Young's modulus value is greater, then even if you apply higher force, you can only create very small change in the length. Okay, deformation will be very small. That is the advantage of knowing the value of Young's modulus. So the steel is having the highest value of Young's modulus, which is around 200 Newton per meter square. So as strain doesn't have any unit, obviously the unit of Young's modulus will be from stress only. That is nothing but force by area, Newton per meter square. Okay. So knowing the value of this Young's modulus will help you in the designing of the building and maybe in the use of crane. Okay, it comes under the application part where I will explain you how this value of Young's modulus will help you to design the rope for the lifting of certain huge materials. Okay. Next one is about shear modulus. So it is a ratio of shearing stress to the shearing strain. Definition is very simple, and if you are too lucky, you will get this as a 3-mark question. See, what are the types of modulus of elasticity? If you are too lucky, only this much. Young's modulus, shear modulus, bulk modulus. If you write this much, you will get 3 marks. So that you need to be very lucky, okay? Now, shear modulus is nothing but the ratio of shearing stress to the shearing strain. So we denote Young's modulus by the letter Y, capital Y, shear modulus with a letter G. It's from NCERT, okay? Now this G is nothing but shearing stress divided by shearing strain. I can write here, what is shearing strain? You have already know that one, right? What is shearing strain? It is nothing but delta X divided by L, right? You have seen from shearing strain in the previous class. From there, what we write? G is equal to F divided by A divided by delta X divided by L. Now what happens? This L goes to the numerator, what we have seen here, see, this L goes to the numerator, right? Similarly, here also this L goes to the numerator divided by delta X. Now you know one thing, L divided by delta X, that is nothing but 1 by theta. Or you have seen, what is this one? Delta X divided by L, oppo by adjacent, that is nothing but tan theta, right? So tan theta is approximately theta only. So what you can do here, we can write L by delta X, that is nothing but 1 by theta. Okay, we will write L by delta X nothing but 1 by theta. Now we can substitute it over here. You can write G is equal to F divided by A, okay, this term 1 by theta. Or if you take this F by A as sigma S, that is shearing stress, okay, if you take this term as shearing stress sigma S, then you can write G is equal to sigma S into theta. Okay, so unit of shear modulus is also Newton per meter square, or we also call it as Pascal. Then the comparison with this Young's modulus and shear modulus is almost 3 times smaller compared to the Young's modulus value. Or you can write that G is equal to Y by 3. Okay. You can see here SI unit is nothing but what we have written is Newton meter square or Pascal. Then whatever I told, it is G is equal to Y by 3. Now next one is about bulk modulus. We denote it using capital letter B. It is a ratio of volume stress to volume strain. Very simple, volume stress to volume strain. Now what you can write here, that is B is equal to minus P divided by delta V by V. So P is nothing but pressure, or we also call it as volume stress. Okay, then I can write this B is equal to minus PV divided by delta V. Okay, we are just taking the rearrangement, just taking this term to this side. Now why this negative sign? This negative sign indicates that when pressure increases, or also it is known to be the volume stress, when volume stress increases, volume is going to get decreased. So you can understand, when a body is kept underwater, okay, and if you increase the external pressure, what happens to the body? Its volume is going to get decreased. Okay, so whatever pressure we feel now, okay, it is nothing but the pressure exerted by the air which is surrounding us. Correct, right? So if you go to higher altitude, you will feel less pressure, okay, because atmosphere is less over there. So that's the reason you will find it difficult to breathe. You must have heard about that. The people who go to Himalaya and all will find it difficult to breathe, and they take the tablet Diamox. Correct, right? So that their breathing will be controlled. Now, this again, the SI unit is nothing but Newton per meter square, or also called it as Pascal. So all these modulus are very simple, and it will be asked mainly for 1 or 2 marks. Okay, 1 or 2 marks it will be asked. You don't need to worry much about that. You can just understand the definition and you can write for the exam. Next one, the reciprocal of bulk modulus, okay, is known to be compressibility. So this is another important term, okay, which is equally important, compressibility. So it is nothing but the reciprocal of bulk modulus. Now it is denoted by letter K. This compressibility is defined as fractional change in the volume per increase in pressure. So when the pressure increases, what actually happens to the volume? So here I have told you, like when a body is kept under water, when you increase the external pressure, okay, what happens? Its body is going to get compressed. But you should also understand that this volume stress is not produced by the external force. Okay, remember the previous class, volume stress is not because of external force, it is because of the internal force. Correct, right? Internal force produced by the body so as to oppose the external force. Okay, that's the reason why this compressibility is opposite to that of the bulk modulus. So bulk modulus tells you ratio of volume stress to the volume strain, and here compressibility tells you it is a fractional change in the volume per increase in the pressure. So here you need to know that volume is going to get decreased. Okay, so K will be equal to 1 by B, or we can simply write it as minus 1 divided by delta P into delta V divided by V. Okay, delta V by V. So if you just read this NCERT textbook itself, you can understand and you can have a good idea of this one. Then you can copy the notes from the board. Okay.